Welcome to my channel, Management Accounting Made Easy. This is part 2 of cost, volume, profit analysis. Here we are going to see the break-even point analysis. At break-even point, there is no profit or no loss is made. After the break-even point, the companies will start making profit. So shorter the break-even points are better it is. So at break-even point, the total revenue is equal to the total cost. So that's why they make no profit or no loss. Now, if you look at the marginal costing formula, which says sales take away all the variable costs equals to the contribution, and contribution minus the total fixed cost equals to the profit. So at break-even point, the total contribution is equal to the total fixed cost. Now, we'll see how to calculate the break-even point in units. So, break-even point in units equal to fixed cost divided by the contribution per unit. Contribution per unit is calculated by selling price per unit take away the variable cost per unit. Now we'll see how to calculate the break-even point in money value, which is fixed cost divided by the contribution to sales ratio. We are going to see an example called Tune Limited. So we'll see this example. Tune Limited manufactures and sells wireless headphones. Variable cost per unit is £15. The contribution to sales ratio is 60%. Monthly fixed cost 675,000. So calculate the monthly break-even point in units. Okay, so they have given the contribution to sales ratio. So the question is, calculate the monthly break-even point in units. Now, we'll see the formula for the break-even point in units, which is fixed cost divided by the contribution per unit. But here they have given us the contribution to sales ratio. So using the contribution to sales ratio, we need to calculate the selling price per unit in order to calculate the contribution per unit. So we'll do that. So we'll say the selling price per unit is X pounds, for example. So instead of the contribution, we can put X, which is our selling price, take away the £15, which is the variable cost per unit. Okay, so that is the contribution per unit, divided by our X, which is the selling price, is equal to 60%. So now we can calculate the selling price, which is our X. So the selling price is £37.5. Because if you solve that formula, you will get the selling price is 37.5. So now we can calculate the monthly break-even point, which is the fixed cost 675,000 divided by the contribution per unit, which is 37.5 is our calculated selling price minus the variable cost, which is our £15. So the contribution per unit is £22.5. So the monthly break-even point in units is 675,000 divided by the 22.5, which is our contribution per unit. So we will get 30,000 units as our monthly break-even point in units. We'll see another example here called Ring Limited. Ring Limited uses marginal costing system. For the coming year, the variable costs are budgeted to be 55% of sales, and the fixed costs are budgeted to be 15% of sales. If Ring Limited increases its selling price by 12%, assuming fixed cost, variable cost per unit, and the sales volume remains constant, identify the effect on Ring Limited's contribution and profit. So first we need to understand the question here. So if they say identify the effect, that means after the increase in selling price, we need to say what will happen to the contribution and the profit. So we'll use a simple example. So we'll have two columns. One is our original contribution and profit, and the next one is the revised one. So if the selling price is £100 now, so after the revision, that means they are planning to increase the selling price by 12%. So the new selling price is going to be £112. Now the variable cost, the original variable cost is 55% of sales, which is £55. But the question says the variable cost remains the same. So the variable cost is going to be 55 even for the revised or the new, under the new price. So the contribution is 100 selling price, take away the variable cost 55. So the contribution, original contribution is £45. But the revised one is £57, which is 112, take away the 55. Now, the fixed cost, the question says, is 15% of sales, which remains the same. So the original sales is 100, 15% of that is obviously £15. So the fixed cost for both situation is going to be £15. So our profit, the original profit is 45 take away the fixed cost of 15, which is £30. But the revised one is £42. So we'll see the effect on contribution and the profit. So the contribution increased by 27% because originally it was 45, now it's 57. So the percentage increase is 57 take away 45 divided by the 45 times it by 100, which is the 27%. And the profit also increased by 40% because the original profit is 30, the new profit is 42. So 40 minus 32 divided by 30 times it by 100, you will get 40%. So here, the contribution and the profit has increased. So we'll see why it has increased, because the only increase is your selling price. The rest remain the same. Now, if you get a similar exam question, use your numbers like this so that you can identify the increase or decrease in contribution and profit. Here we are going to see how to calculate the break-even point and the effect of change in break-even point when fixed cost reduces using an example called the Carry Cool Limited. So we'll see the question. The Carry Cool Limited is a handbag manufacturing company. It is considering to sell its machineries and planning to hire them only when they needed it. Currently, the fixed overheads incurred from maintaining the machines is £69,900 per annum. If they rent the machines on a daily basis, it would cost them £2,250 per day, which can be used to make 150 handbags in one day. Carrico Limited incurs other fixed overheads of 250,000 per annum. Selling price per handbag is £250 and the variable cost per handbag is £110 per handbag. Explain the effect on both break-even point and the operating risk of Carrico Limited due to its change in policy. So here what is happening? So having those machineries, the company is incurring £69,900 of fixed cost per annum. So what they're trying to do, they're trying to sell those machineries and they want to hire them whenever they need it. So the rental cost for those machineries is 2,250 per day. So before that, £69,900 was fixed overhead. Now they're going to hire it on a daily basis. So this £2,250 becomes as a variable cost per day, because they're not going to keep it forever. They're going to hire those machineries whenever they need it. Now, the other fixed overheads is 250,000 per annum, and they have given the selling price per handbag and the variable overhead per handbag. So now we need to show the effect on both break-even point and the operating risk of Carrico Limited. We're going to have a quick look at the question. Fixed overhead incurred from maintaining the machineries is 69,900 per annum. So the company is planning to sell those machineries and they're planning to hire them whenever they need it. So the rental cost per day is 2,250 and in a day they can make 150 handbags. So this rental cost is becoming a variable cost after the change in policy. Other fixed cost of 250,000 per annum, this 250,000 per annum is going to stay the same. And they have given the selling price per handbag and the variable overhead or variable cost per handbag is also given. Now we'll calculate the existing or current break-even point in units. So we know the formula, which is the total fixed cost, that is 250,000 plus the 69,900, which is equal to 319,900 divided by the contribution per unit, which is the selling price of 250, take away the variable cost of 110, so that is 140 pounds per unit. That is the contribution per unit. So the existing or current break-even point is 319,900 divided by 140, that is equal to 2,285 units. So at the moment, the company has to sell at least 2,285 units in order to break even. And if they want to make profit, so they have to sell more than 2,285 units. Now, after the change in policy, we'll calculate the new break-even point. Now, there will be no 69,900 of fixed overhead because they're going to sell those machineries. So the new fixed overhead is going to be 250,000. But we have to remember there is going to be an extra variable cost, which is the rental cost. So the extra variable cost per unit is 2,250 divided by 150, which is £15 per unit. So at the moment, there is variable cost of 110. On top, we got to add the extra £15. So our total variable cost is going to be £125. So our new break-even point is going to be fixed cost, which is 250,000. As I mentioned before, there will be no 69,900 because they have sold the machineries. So 250,000 divided by the new contribution, which is 250 is the selling price. Take away the total variable cost is £125. So 250 take away 125. Our new contribution is £125 per unit. So the new break-even point is 250,000 divided by the new contribution, which is 125 per unit. So the new break-even point is 2,000 units. So when the fixed cost reduces, the break-even point is also reducing. So here, the break-even point has gone down from 2,285 units to 2,000 units. So when fixed cost reduces, the break-even point also will reduce, so as the operating risk. So the effect will be the break-even point will be reduced by 285 units, and also the operating risk will be reduced due to the reduction in fixed cost. In this example, we are going to see what will happen to the break-even point when the selling price and the variable cost changes. So the example is called the Mancell Limited. So we'll read the question. Mancell Limited buys and sells printers for home use. Selling price per unit is £65 and the variable cost per unit is £25. Fixed overhead is estimated for the next period is £75,840. Due to the increased competition, the selling price per unit is expected to reduce by 10% and the variable cost is expected to increase by 5%. Calculate the percentage change in Mancell's break-even point due to the change in circumstances. So we'll see. So we'll calculate the original break-even point in units. We know the formula, which is fixed cost divided by the contribution per unit. So the fixed cost is 75,840 divided by the existing contribution per unit is selling price per unit is £65. Take away the variable cost per unit is £25. So the contribution per unit is 40. So the existing break-even point is 75,840 divided by the £40 contribution per unit. So the existing break-even point is 1,896 units. Now, due to these changes, the break-even point also going to change because the selling price is going to be reduced by 10% and variable cost is increasing by 5%. So the contribution per unit is going to change, but the fixed cost is not changed. So the new break-even point, we need to calculate the new break-even point. So for that, the fixed cost 75,840 divided by the new contribution per unit. So the selling price is reduced by 10%. So the new selling price is £65 times 90%. So that is equal to £58.5. That's our new selling price per unit. Now the new variable cost per unit, existing variable cost is £25 per unit. Now this is increasing by 5%. So 25 times 1.05, so that's equal to £26.25. So our new selling price is £58.5. The new variable cost per unit is £26.25. Therefore, our new contribution per unit is £32.25. So using this information, if we calculate the new break-even point, that will be the fixed cost 75,840 divided by our new contribution per unit, which is 32.25. So the new break-even point in units will be 2,352 units. So now, before, we had to sell 1,896 units to break even. Now, after these changes, our new break-even point has increased to 2,352 units. So the percentage increase in break-even point is 24%, which is 2,352. Take away 1,896. That is 456 units. That is the absolute increase. Divided by 1,896 times it by 100, we will get this 24% increase. We are going to see different types of examples. Another example here is to calculate the fixed cost. So the example's name is your water bottle company. Okay. So the question is, your water bottle company produces and sells insulated water bottles. The budget for the first quarter for the year ended 31st March 2022 shows the budgeted number of bottles is 8,500 units. So this is the maximum number of bottles they're planning to sell for that quarter. Selling price per bottle is £12.50. Budgeted contribution to sales ratio is 30%, and the margin of safety is 82%. Okay, we haven't talked about the margin of safety so far, but I will be uploading another video on margin of safety. But for the time being, we'll see what is margin of safety. Margin of safety means the difference between the maximum number of units a company can sell. In this question is 8,500 units and the break-even point. So the difference between the maximum number of units a company can sell and the break-even point. So in this case, they have said margin of safety is 82%. So the break-even point is 18%. Okay. Now the question is, we need to calculate the fixed cost for the first quarter. At break-even point, we all know contribution is equal to the fixed cost. Because if you look at the margin of costing formula, sales take away all the variable costs equals to contribution. Contribution take away fixed cost is equal to the profit. So if the profit is equal to 0, then your contribution and the fixed cost should be the same. So at break-even point, contribution is equal to the fixed cost. So if we calculate the contribution at the break-even point, then we can say this is the fixed cost. Okay, so first we'll calculate the break-even point in units. Okay, the maximum number of units is 8,500 units. The margin of safety is 82%. As I mentioned before, the break-even point is 18% of the maximum number of units the company can sell. So 18% of 8,500, which is 1,530 units. That's our break-even point. Now we'll calculate the contribution at break-even point, which is the number of units, 1,530, times the contribution to sales ratio they have given is 30%. So times 30%, times it by the selling price, which is £12.50. So our contribution at break-even point is £5,737.50. This is our fixed cost. So the fixed cost is £5,737.50, which is similar to our contribution at break-even point. Here we are going to see the break-even point with step fixed cost. The example is called the Rainbow Squares Limited. So we'll see the question here. Rainbow Squares Limited is a birthday card manufacturing company. The fixed cost of 45,000 is expected to increase to 90,000 once the production of a specific birthday card exceeds 25,000 units, as extra space is required for the extra units produced. So here, up to 25,000 units, your fixed cost will be £45,000. And when the production level increases beyond 25,000 units, we need extra space for the extra units produced. So the extra fixed cost is going to increase to £90,000. There will be no change in variable cost per unit. It stays at £3.50. Selling price per card is £6.50. So there are three questions we need to answer here. One, we need to formulate the total cost equations, and we need to prepare a break-even chart, and also we need to discuss the implications of the break-even points from the graph and the company's production plans. So every time when the fixed cost changes, the break-even point also, say here, there are two fixed costs. So we will be having two break-even points. Okay, the Rainbow Squares Limited example continues. So we'll see the summary of the question. So the first 25,000 cards, the fixed cost is going to be £45,000. And when the production exceeds more than 25,000 cards, the fixed cost is going to be 90,000, and we know the variable cost is £3.50 per card, and the selling price also £6.50. Now, the first part of the question, we need to have the total cost equations, because the fixed cost is changing. So our total cost also will change. So the first one, the total cost, we know fixed cost plus the total variable cost. So say the total number of units the company is producing is X number of units, for example. For 25,000 units or less than 25,000 units, the total cost is going to be £45,000, which is our fixed cost, plus the total variable cost, which is X units we are going to produce. 3.5 per unit is our variable cost. So the total variable cost is 3.5x. So our total cost equation for 25,000 units or up to 25,000 units is 45,000 plus 3.5x. If you're going to produce more than 25,000 units, our total cost is going to be the fixed cost, which is 90,000 plus 3.5x. So these are the total cost equations. Okay, we'll see the graph now, which is our parts B and C. So our x-axis is going to be the number of units and our y-axis is going to be the cost and revenue, that's in money value. So if you look at my green line, that is our total revenue, because always the total revenue will start from zero, because if you sell no units, your total revenue will be zero, and when we sell more units, the revenue will increase. So the green line is our total revenue. Now we'll look at our red line or brown line, that's the total cost line. So can you see from the graph, up to 25,000 units, the fixed cost is £45,000. And when the production increases beyond 25,000 units, the fixed cost is increased to £90,000. Okay. Now, as I mentioned before, when there is a change in fixed cost, there will be a change in the break-even point as well. So here there are two changes in fixed cost. So we will be having two break-even points. So the first break-even point is at 15,000 units. We can calculate it because fixed cost, which is 45,000, divided by the contribution per unit, which is selling price £6.50, take away the variable cost per unit, which is £3.50. So the contribution per unit is £3. So the first break-even point is 15,000 units. Now, if you calculate the second break-even point, which is the fixed cost is going to be £90,000, but the contribution per unit is going to be £3. So the second break-even point is 30,000 units. So this is all the graph is showing. So we have answered the part B. Now we are going to answer the part C. So we can see from the graph that the production of birthday cards are profitable between 15 to 25,000 units, because you can see the total revenue line is above the total cost line. So between 15,000 to 25,000 units, the production of birthday cards are profitable. But after 25,000 units and up to 30,000 units, after 25,000 units and up to 30,000 units, the graph shows that the total cost line is above the total revenue line. Therefore, it is not profitable to produce between 25,000 to 30,000 units. But any units produced above 30,000 units is profitable, because after 30,000 units, if you look at the graph, the total revenue line is above the total cost line. So the company's production plan should be between 15 to 25,000 units, or they can produce more than 30,000 units. So the company should set the production targets accordingly. So by looking at the graph, if your total revenue curve is above the total cost curve, then it's worth producing, and vice versa. Here we are going to see a slightly complicated example called Fresh Juice Company. The Fresh Juice Company sells fresh fruit juices. When the sales is £5.5 million, the total cost will be £3.75 million. When the sales reaches £7.5 million, the total cost will be £5.25 million. There will be a step fixed cost of £750,000 when the sales revenue reaches £7 million. Calculate the break-even sales revenue. So we can see here, they're not talking about in units, they're talking in money value. And also the question they are asking to calculate the break-even sales revenue. Now, we know the break-even point in money value formula, which is fixed cost divided by the contribution to sales ratio. In this example, they haven't given us the CS ratio or the contribution to sales ratio. We need to calculate the contribution to sales ratio. So the first step, we need to calculate the variable cost per pound of sales. So if you know the variable cost per pound of sale, you can calculate the contribution per pound of sale. So in order to calculate the variable cost per pound of sale, we need to use the high and low method. So when you do the high and low method, you mustn't forget to deduct the step fixed cost, which is included in the 5.25 million total cost. Okay, and we need to assume there is no step fixed cost. So we'll do the high and low method now. When the sales revenue is 7.5 million, the total cost without the step fixed cost is 4.5 million, which is 5.25 million take away the 750,000. And when the sales is 5.5 million, the total cost is 3.75 million. We can straight away take that 3.75 million because that doesn't include the step fixed cost. Now we'll calculate the variable cost per pound of sale. So when you take the difference between the sales is 2 million, and when you take the difference between the total cost, which is 0.75 million. As we know from our previous knowledge of calculating high and low method, when you deduct the total cost from one level to another, the fixed cost will be eliminated because the fixed cost is constant, so that will be eliminated. So here the difference of 0.75 million is the difference in the variable cost. So the variable cost per pound of sale is 0.375, which is, the 0.75 million divided by the 2 million, we will get 0.375. So 0.375 pounds is the variable cost per pound of sale. So therefore, the contribution per pound of sale will be 0.625 pounds, which is 1 minus 0.375. Now, we know when there is a step fixed cost, there will be 2 break-even points. So the first fixed cost will be, if you substitute the variable cost, which is 0.375 in one of the lines. So I'm going to take the first line, which is 4.5 million is our total cost. Take away the total variable cost, which is 7.5 million is our total sales. times it by 0.375. So our total variable cost is going to be 2.8125 million. So from the total cost of 4.5 million, if we minus the 2.8125 million, you will get the fixed cost of 1.6875 million. Now, with the step fixed cost, our fixed cost is going to be 1.6875 million plus the 750,000. So you get 2.4375 million. So first we have calculated the fixed cost without the step fixed cost, and then we have added the step fixed cost of 750,000 to get the second fixed cost, which is 2.4375 million. As we know, whenever there is a step fixed cost, there will be two break-even points. So when the fixed cost is 1.6875 million, the break-even sales revenue will be 1.6875 divided by the contribution of 0.625, so 2.7 million. That's our first break-even sales revenue. Now, the second break-even sales revenue is the fixed cost of 2.4375 million divided by the contribution of 0.625. So you will get 3.9 million pounds. We are going to see the basic break-even chart. So we can see the sales revenue line, total cost line, fixed cost line. So the difference between the total cost and the fixed cost is our variable cost. And we can see the break-even point, 3,000 units, and the maximum units we can sell from the graph is 15,000 units. So from this, we can calculate the margin of safety, which is the difference between the maximum number of units of 15,000, take away the break-even point 3,000. So the margin of safety is 15,000, take away the 3,000 is the 12,000 units. And also from the graph, we can see the loss area. So in the loss area, you can see the total cost line is above the sales revenue line. So the loss area is up until the break-even point. And after the break-even point, you can see the profit area where the sales revenue line is above the cost line. Okay, so now in the exam, they can ask you questions from the graph. So from this graph, if they have asked you what is the total contribution at 15,000 units. Okay, so first we need to calculate the contribution per unit. So if you look at the break-even point in units formula, which is break-even point in units is equal to fixed cost divided by the contribution per unit. So here we know the break-even point, which is 3,000 units. We know the fixed cost, which is 7,500. The only thing we don't know is the contribution per unit. So if you apply that formula, the 3,000 units is equal to the fixed cost 7,500 divided by the contribution per unit. So the contribution per unit is 7,500 divided by 3,000. So that is £2.50. So if we know the contribution per unit, we can calculate the total contribution at 15,000 units, which is 15,000 units times £2.50, that is £37,500. So the total contribution is £37,500. We are going to see the contribution break-even chart. If you look at the y-axis, there is costs and revenues, and the x-axis is the number of units. We can see the loss area, profit area, total cost line, fixed cost. That is the difference between the variable cost line and the total cost. Here we can see the margin of safety. Also, we can see the contribution. So we know the contribution is sales take away the variable cost. So from the graph, you can see the contribution. We are going to see the profit volume chart. So the profit volume chart, if you look at the y-axis, so the fixed cost is minus 65,000. So the loss area is the pink area, and the dark green area is the profit area. But if you look at the whole green area, including the dark green as well as the light green, is the contribution area. So any point within this big triangle, which is the contribution area, is the contribution. Now, from this graph, if they ask you to calculate the contribution to sales ratio, for example, if the selling price is £5 per unit. Okay, so from the graph, we can see they have sold 68,750 units, and the selling price per unit is £5. So the total sales is 68,750 times the £5, which is 343,750. That is the total sales. Now, the total contribution is fixed cost, which is 65,000, plus the profit of 155,000. Because if you look at the marginal costing formula, contribution take away the fixed cost is profit. So profit plus fixed cost is the contribution. So here the fixed cost is 65,000. The profit is 155,000. Therefore, the total contribution is 155,000 plus the 65,000, which is 220,000. So the contribution to sales ratio is the total contribution 220,000, which we have seen 155 plus the 65, divided by the total sales, which is 68,750 units, times by the selling price per unit, which is £5, which is £343,750. So the contribution to sales ratio is 64%. We'll see the assumptions of break-even chart. So the first assumption is all cost can be segregated into fixed and variable costs, including the semi-variable cost. We know the semi-variable cost has a fixed element and a variable element. And the second assumption is fixed costs will not change in relation to the level of activity or production. So fixed cost is going to be constant throughout. The next assumption is variable cost varies in direct proportion to the level of activity. For example, if the variable cost per unit is £4 per unit, and if a company produces 100 units, the total variable cost will be £400. And when they produce 1,000 units, the total variable cost is going to be £4,000. So this means Variable cost per unit is constant at all levels of activity. Only the total variable cost varies in direct proportion to the level of activity. The next assumption is selling price per unit is constant. So even if the production increases, thereby the supply will increase, or whatever happens, say even if there is competition in the market. So the break-even chart assumes the selling price will be constant, selling price per unit. And they say the product mix will be constant. Say the ratio, say if a company produces two different types of products, say one product 60% and the other one is 40%. So the product mix 60 to 40 stays the same. Now, we have seen these assumptions of break-even chart, but these assumptions can become the disadvantages of break-even chart or limitation of break-even chart. So we'll see. So here they said fixed cost will be constant at all levels of activity, but in real life the fixed cost will not be constant for all levels of activity. So when the production level increases, the fixed cost will increase. Same way, the next assumption, variable cost per unit is constant. No, variable cost per unit will not be constant always. Say, for example, when you buy bulk quantities of materials, your variable cost per unit will go down because of the quantity discounts you get. And the other assumption says selling price per unit is constant, but selling price will not be always constant. For example, if the supply increases, the company has to reduce its selling price, or if the competition increase in the market, the company has to reduce its selling price. And the proportion of product mix also will not be constant always. So these are the main limitations of break-even chart. So in this one, we have seen the assumptions and the limitations of break-even chart. So we are going to see the advantages of break-even chart. So the break-even chart helps to identify how many units are required to be sold to start making profit. So this means it will help to identify what output or sales is required to achieve the break-even point, and thereafter the profit. We all know the companies can make profit only after reaching the break-even point. So lower break-even point is good for the company. So this will help the business to identify the risk involved in a product mix, because if the break-even point is high, the risk is also high. The second one, the relationship between cost, volume, and profit are presented in simple form to understand and analyze. The next one, it helps managers to make correct decisions, because the managers can choose the most profitable product mix using the break-even chart. The other one, the cost control is facilitated, because the chart shows the relative importance of the fixed cost and variable cost. Also, the break-even chart emphasizes the importance of keeping the fixed costs down, especially for a new startup business. As higher the fixed cost, higher the break-even point. We have seen in our previous examples. So high break-even point is not good for the business, as the business has to wait for longer period to make profit. And finally, the break-even chart helps to fix the best selling price to achieve the desired profit. Thank you for watching. If you like this video, please like, share and subscribe. I'll see you in multi-product break-even analysis.